These are your 3-1C notes on graphing linear equations. We're going to graph lines again. This time, though, we're going to graph them, rather than using a table, we're going to use X and Y intercepts. So just another approach, still graphing a line, still the line is all the ordered pairs that work for that equation. It's all the solutions. So in order to use X and Y intercepts, we've got to understand what those are. An x-intercept is the x-coordinate of a point where the graph crosses the x-axis. So intercept, I think of like an interception. It's where it crosses the line. And then a y-intercept is the y-coordinate of a point where the graph crosses the y-axis. There are two different points usually, unless it's the origin. The only time that the x-intercept and the y-intercept can be the same point is the origin. So if you look at the ordered pairs, it's x comma 0 for the x-intercept, because if you're going to cross the x-axis, you can't go up any and you can't go down any. You have to be on the x-axis. And so if you're not going up or you're not going down, your y value is equal to 0. And then for your y-intercept, you're not moving to the left any and you're not moving to the right any. And so your x value is equal to 0. And so it's here, 0, 2. And so when you have those 2 points, those are 2 critical points, a point on the y-axis, a point on the x-axis, you can then use those 2 points to make your nice straight line. So you connect and extend from there. We are drawing a picture of all the solutions. We cannot name all the solutions of an equation, so we can just draw a picture and say if the ordered pair falls on that line, it's a solution to that equation. So at the y-intercept 2, the x-coordinate is 0. At the x-intercept of -4, the y-coordinate is 0. We use those 0 values to find the x and y-intercepts. So we're going to find the x-intercept and the y-intercept of the following linear equations. So right now, here's our equations. We're going to see where these would cross the x and y axis. So a lot of times we just label them as xint for x-intercept. And so to find the x-intercept, x has to be part of the equation. And I'm going to take that equation, 4x, but instead of saying minus y, I'm going to say minus 0. I'm going to replace y with 0, because we just saw on the last slide that your y value is 0 when it crosses the x-axis. What that does is it creates an equation just like we had in Chapter 2. I'm going to clean it up. 4x is equal to 4. Divide by 4, divide by 4, x is equal to 1. So my x-intercept is the ordered pair 1, 0. The 0 is because I replaced my y value with 0. For the y-intercept, I'm going to replace the x with 0. So for my y-intercept, I'm going to take the same equation, 4x minus y equals 4. Where I see the x value, I'm going to replace that with 0 and solve for y. And so 4 times 0 is 0. 0 minus y is equal to 4. Or negative y is equal to 4. So if negative y equals positive 4, positive y equals negative 4. You can switch the sign of each. So my y-intercept is 0, negative 4. It's an ordered pair. For the second equation here, I can do, for my x-intercept, I can replace y with 0. So for x-intercept, I'm just going to show my work and label it. 0 equals negative 3x plus 7, which means I'm going to subtract 7 from both sides. Negative 7 is equal to negative 3x. Divide by negative 3. And my x-intercept is equal to 7/3. It's not always a pretty number. So my x-intercept is 7/3, 0. For my y-intercept, just to label my work, I'm going to plug 0 in for x. So when you're trying to find your y-intercept, y has to be part of your equation. If you're trying to find your x-intercept, there better be an x inside your equation. So y equals 7, because 3 times 0 is 0, so we have y is equal to 7. So my y-intercept is the ordered pair 0, 7. And the last one, x is equal to y plus 3. Doesn't matter what order these things are in. All of them have. They're aligned, so they cross the x and y axis. So for my x-intercept, I'm just going to plug 0 in for y. 0 plus 3 is 3, so that was easy. So my x-intercept is 3, 0. For my y-intercept, I'm going to plug 0 in for x, and I get y plus 3. To solve for y, I would subtract 3 from both sides, and I get y is equal to -3. So my y-intercept is 0, -3. All right, so if we want to graph using these x-intercepts and y-intercepts, you're going to find them just like we did on the previous page, and then we're going to plot the x-intercept on the x-axis, plot the y-intercept on the y-axis, and connect and extend to graph all of the solutions ordered pairs of that linear equation. We don't just connect them, we go beyond them, and that's representing all of the ordered pairs that fall on that line. So we're only using these 2 points to find all the points. Okay, so when we find my x-intercept here is when y is equal to 0. So I'm going to say 0 is equal to 3x plus 2. Solve for x. I'm going to subtract 2 from both sides. I get -2 is equal to 3x. Divide by 3. My x-intercept is equal to -2/3. So I have an ordered pair, -2/3, 0. So on the x-axis, I'm going to type in -2/3, which is like -0.6 something, right about there, right close to -1. For my y-intercept, I'm going to plug 0 in for x. Y is equal to 3 times 0 plus 2. Y is equal to 2. So my y-intercept is 0, 2. And so I'm going to go up 2 on the y-axis, and then I'm going to connect and extend those 2 lines. So you can use a ruler, go beyond. Those are all the solutions of that line. For number 5 here, we're going to do our x-intercept when y is equal to 0. X plus 0 is just 2, so my x-intercept is 2, 0. My y-intercept is when x is 0. I plug 0 in for x, and I get y is equal to 2. So I have 0, 2 also. They can be the same numbers. They just can't be the same point unless of the origin. And so my x-intercept was a +2. My y-intercept was a +2. That was a lot less work than number 4. It happens that way sometimes. Sometimes you got to show a lot of work, and sometimes it's pretty simple. And so I connect and extend, putting arrows on each end to say forever and ever. And number 6, when I try to find my x-intercept, I plug 0 in for y. I divide by -3, and I get my x-intercept is equal to 0. So when y is 0, x is 0. When that happens, I actually have my y-intercept too. Because when you're at 0, 0, your x-intercept is your y-intercept. They're both the same point. When this happens, you can't graph using x and y-intercepts. So what we have to do is resort back to our table, because you only have 1 point. And if you only have 1 point, you can't connect anything. So I'm just going to plug in a couple more points just to see how this line is going. Because I don't know if this line is going to the right, going to the left, how steep it is. So if I plug in a couple points, so to find 1, I'm just going to plug in x is 1, I get -3. When I plug in x is -1, I get +3. So I have 2 more ordered pairs to help me out. So 1 gives me -3, and -1 gave me +3, and now I have a line. So again, even if they ask you to use x and y-intercepts, if they ask you to use them and your x and y-intercept is 0, 0, you have a problem. You can't use it to graph. Here's a word problem. It's just getting you used to using a table of values. So actually, when you look at it, this is the least amount of work, but I know we get lost in all the words. So a swimming pool is being drained at a rate of 720 gallons per hour. We just drained our swimming pools up here in Michigan because of the winter. The table shows the function relating the volume of water in the pool and the time and hours that it's been draining. So if you look at the table of values, when time was 0, there was 10,000 gallons of water in the pool. After 2 hours, there was 8,000. All the way down to 14 hours, there was 0 water in the pool. So it says find the x-intercept and the y-intercept. You don't have to do any work. There's no equation. Just use your brain. So the x-intercept is when my y value is 0, and my y-intercept is when my x value is 0. So I'm going to look in the table of values, and my x-intercept is 14, 0. And my y-intercept, when I look at the table of values, was 0, 10,000, 80. Part B asks us to describe what that means. And what it means in terms of hours and gallons before I started draining my pool, I had 10,080 gallons of water in it. The y-intercept is before something happens. Time didn't happen yet. I didn't start draining yet. It's the initial amount. So get initial, oops, I spelled that wrong. Y-intercept, anytime they ask you for that, think about the initial value. Initial amount, initial height, depending on what they're talking about. In this case, initial gallons of water. Before, in the beginning. That's what initial means. Okay? So your lesson summary here. I hope I switched it. I can't remember. I did not. Give me 1 second. Okay, sorry about that. So I need you to figure out what value do you substitute for y if you're trying to calculate the x-intercept. And in example 7, the last problem we did, the word problem about the pool, what does the x-intercept mean in that situation? So we described the y-intercept. I'd like you to describe the x-intercept. Good luck.